Sustainable energy, I think we all know that this is the word that the world is speaking now. And the humans have been so irresponsible all these years, and we have brought our earth in such a state that sustainable energy systems and this particular area is going to be the focus for the entire world, right? So we have three great eminent speakers who are going to talk about the different aspects of this area. I would give a very short introduction, but at the same time, you will see that on the presentation, on screen, you will be able to see the detailed biodata of the speakers. I would just give you a line about what they're going to speak, and then we'll move on to the session. We have Dr. Rajaram, Founder Director, Kriti Labs Private Limited. He would be talking on sustainability, technology, and the opportunities available in this area. We have Mr. Manu Iyer, Director, P&M, National Small Industries Corporation, and he is going to touch this session from the investor perspective. And then we have Dr. S. Gomati Nayagam, IPMA. He is a Certified Project Director, Chartered Engineer, and the Fellow of the Institute of Engineers of India. And he is going to be talking about a very interesting area, that's the opportunities in the STEM and non-STEM students. So let's welcome them. And over to you, Dr. Rajaram.
Thank you, and good afternoon to all of you. I know that after lunch, having a sustained energy in this kind of listening to a talk is going to be difficult, in spite of the title being Sustainable Energy Systems and Technology role in that. But let me get started and see how best I can fulfill my role here as a person to talk on this subject. Well, to start with, next slide. Okay, so this is what I'm going to talk about. A brief one or two slides on Kriti Labs. Technology is our company, which we have formed. Basically, you can see that we are in every human endeavor that is challenged by geography or by process complexity or by vagaries of human nature on which certain very critical things may be dependent on. We'll then go on to some little discussion on what is sustainable energy and what sustainable energy systems are about, and how they are very important for us in terms of sustainable living on this planet and climate change and so on. And then we would go on to see what is the role of technology. Is it destructive? Is it the cause? Or is it going to be the remedy to help us sustain the planet here with the use of renewable energies? And finally, more important topical interest would be to see what kind of opportunities we have in either as job opportunities or entrepreneurial opportunities, to look at the current scene and see how these things are going to help us to achieve what we want to achieve. So this is about Kriti Lab. As I said, we are into everything. Chiefly, our main domains are in oil and gas, dairy, jewelry, and so various minerals and chemicals, and we are into several domains, so we are not a single domain company. We are an IoT company, a technology company, where we apply our technology to whatever issues and problems that arise in companies across domains. Okay. So that's just another slide to show our variety of use cases that we have. And why does it jump? I don't know.
May we request the audience to be a little silent so that everyone hears? Thank you.
Okay. So sustainable energy, We all know what it is, and intuitively we can also see that what is not fossil fuel or what is not, which does not deplete our resources from the earth, is indeed, if we can use that, that is sustainable throughout for the next hundreds of years. In a sense, our generation, you can see my white hair, so our generation which has, which were born around the independence in 1940s or between 50s, we have sort of exploited the resources of the earth to such an extent that you young people around here, I think we have done a great injustice to you people in the sense, and we would like that you are more aware of these things now, and you make sure that you don't do it for further generations to come. Because what we have done is to use up the fossil fuels that took millions of years to become useful to us. Within about maybe 50, 60 years or 100 years, we have almost depleted all of them. So now we are looking for alternate energies, and renewable energies are something that at least do not pose a problem of being limited in the next few hundred years. And in that category, we have solar energy, wind energy, biomass, and so on, which essentially are renewable in the sense that you can keep getting the supply of that from whatever source we are getting. Solar energy from the sun, wind energy from the way wind systems are there around the world, tidal energy, or even biomass where the human output and animal outputs can be used for generating energy. So these are renewable energies, and what we are now looking at is our focus is more on sustainable energy systems. Now, systems are those that are involved in generating these energies, whether it is solar or wind, or we do have some technologies that are needed to be deployed to generate these energies, retrieve them from nature, and then we need to store them and transmit them, and finally to use them. So wherever systems are used in these entire life cycle of energy generation to use, end use, we call them as sustainable energy systems. And we will see how these play a big role in what we are likely to face in the next future. Well, sustainability has another connotation of climate change in the sense that sustainable energies are those which do not deplete the earth resources, right? Whereas even if even after whether they deplete or not, the way we use it, and if that causes a lot of problems in the atmosphere, the lot of pollution and so on, it is going to create a problem in terms of climate change. Climate change has been happening for the last 100 years or so, but only last few decades have we taken cognizance of that. And there were many non-believers so far, but now I think mostly everybody has come around to the fact that global warming is a problem that requires to be tackled. And this sustainability and managing climate change they are very, very interlinked. And we need to take both of them together to tackle them, because climate change is going to give rise to problems like global warming. Already, I think we are talking about it can go to 2 degrees centigrade annually if we are not careful, but we are now trying to limit it to 1.5 degrees. And even then, you can see the heat every year, the climate is different. Either we have severe winters, severe summers, there are flash floods everywhere, at least in many places. And certain cities are Mauritius, for example, is likely to go under the sea in in about 100 years or so. And there are other places like Holland and so on. They are also threatened by being submerged. So these are all major problems of climate change, which in turn is a problem of using fossil energies rather than sustainable energy. So these whole things are all linked together. Now, okay. So now let us come and let us look at what is the role of technology that is being played as far as sustainability and climate change is concerned. If you take the first time certain things were put in place historically, which has led to sustainability problems, that was somewhere in the 18th century, to be more precise, somewhere around 1780 or so, when the Industrial Revolution started in the Western world. Until then, I don't know how many of you know, but India was at the peak in terms of technology for the world. So some of my young friends who are not very conversant with history, it might or conversant with the wrong history, I can say, might come as a surprise. But India was generating 25% of the world GDP. So you can imagine a single country, by far the biggest in terms of economy and technology generation, was there right from 500 AD to about 1700 AD. India was on top. And it's not really a coincidence, but East India came to India around the 1700 AD, and the Industrial Revolution also started around that time. And ever since then, the systems of the world have exploited nature. The whole Industrial Revolution that took place around the 18th century was mostly geared for dominating nature in the sense that the whole philosophy was that, the Indian philosophy earlier was that we are all part of this nature. Even today we have many of our philosophies and religious practices which admire nature, which pray to nature. And most of our skilled artisans believe that they are part of nature. Whereas the Industrial Revolution ushered in an era where people felt that they are superior to nature. They are not part of nature, but they are outside it. And nature, with all its bounties, is there to be exploited. And that is how, if you see every industry and every technology that grew out of Industrial Revolution, right, starting from mechanical first to then electrical, then put to use in various mining and other areas, and then chemical technology that came in, which accelerated the fossil fuel usage of items like petroleum and diesel and so on. And this led to, until now, this has been a steady erosion of the resources that we've had, and it has led to such severe problems now. So, whereas if you see now, then we saw this Industrial Revolution 2.0, which started in 1900. I've just covered that. It came up with the chemical engineering being a big part of that century development, and which led to a lot of fossil fuel extraction from the earth, and the entire economy of various countries revolved around that. Politics, war, everything revolved around the rich oil fields that were there across various parts of the country. Until now, where we've just about started to realize very seriously, there have been a lot of noises and voices being heard about how bad it is for our sustainability, but only now with the Paris Agreement, there is some semblance of acceptance of the fact that we need to do something now, otherwise our life on earth is doomed. So we've started realizing that, and in that sense, how do I go to the next slide? No. Okay. Not known. Anyway, I will just skip that because this is not working. So basically, the next thing that I wanted to tell you was that now we have emerging technologies with the climate of various recognition of the fact that we are in a deep problem which requires to be solved. The emerging technologies are now very, very handy in trying to solve these problems. The technologies such as Internet of Things, the machine language, and it's not working. Can you please try that? Or you please try. When I tell you next slide, you go to the next slide. So the technologies now, if you see, until this 2000 or 2010 or so, we still had very destructive technologies. But now the technologies that are emerging are addressing several of these issues. As I said, Internet of Things, the machine learning technologies, the artificial intelligence, the 5G network, these are all, at least there is a lot of promise that we can deploy these technologies to provide sustainable energy and renewable energy in a manner that without compromising on our lifestyle and our quality of life, we can continue to enjoy these benefits but not get into the old problem of climate change and sustainability issues. So how do these technologies help? This is precisely because if you look at energy, right from its generation to its storage and distribution to end use of this energy, there's a lot of opportunity for these technologies to be used. So far, we were not very competent to tap these energies very efficiently, and there was a lot of waste. For example, even in power transmission, there was a lot of transmission loss across over the transmission wires and all that, and technologies have now slowly improved to reduce those transmission losses. Similarly, in various places, including automobiles that are using petrol and diesel, the earlier vehicles were not at all fuel efficient. Now slowly we have introduced technologies like fuel injection systems and anti-braking and so on, which generally addresses how best to harness our technology to, at a much finer and granular level, to save on energy or to ensure that the energy is not wasted. That is where the technology is starting to play a major role as we go along. And if you look at these technologies and what is in it for me, I see a lot of young friends here, young students and entrepreneurs who are likely to be entrepreneurs. The opportunities are tremendous now, mainly because of this change. I took you through this kind of background to show you that things have changed quite a lot now for you to have tremendous opportunities, because the traditional jobs of programming and IT service and so on and so forth are going to slowly lose their importance. In fact, even there are technologies like no code, low code, where coding itself may become redundant, and most of the people who are earlier aspiring to become a software engineer in some big service-oriented company may have to change their vision now. Basically, your opportunities for you are tremendous in terms of various aspects. Anything that you see, if you are likely to be an entrepreneur, you can see that there is an opportunity. If right from anything that you read in the papers, even today, a couple of days you saw there was domestic violence, or if you see that there is elephants crossing the track are getting killed because of lack of technology to detect when they are coming, and at the same time we can't stop trains for these elephants. But with all these things can really be addressed now with a lot of opportunities are there. Entrepreneurs, this is the best time for you to be involved in getting into startups and start new things, new ventures, because there's going to be tremendous opportunity for you everywhere. So new opportunities, because the focus has now shifted from the old way of exploiting nature to conserving energy, to seeing how we can make this world more sustainable. Next slide. Yeah. So we want to prepare for the future, then we should look at all these opportunities and not go by the traditional aspirations that your previous batches might have had. Right? You need to look at your own domain expertise. You need not be a great programmer or a great IT specialist. If you are a mechanical engineer or a chemical engineer or any domain in which you have you are in with whatever discipline you are in, that domain expertise itself will be of great value going forward, because you can use that domain expertise in every problem that exists in the world. Each of it would require domain expertise added to the Internet of Things and machine learning and artificial intelligence kind of thing. Yeah. Okay. So you need to really take care of the fact that everybody rushing into, there was a time when whether you did mechanical or mining or chemical or whatever, finally you landed up in a job which required you to do IT coding or customer support or some such thing in the services sector. You don't have to really think again in those lines. Basically, your own domain expertise is what you should specialize in, and you should become thoroughly competent with that, because that is what would be required. And the people who would be in the IT kind of jobs would be your support system. In fact, you would try and solve the problem with their help in IT technology. So I would strongly suggest that look at the world around you, look at the world through the newspapers, or look at the world through your own experiences. See and empathize with the problems that are all there. The problems are galore. There are so huge number of problems. If you can identify anything and which you feel because of your domain expertise, it is you can solve it. If you look at the traffic problem, or if you look at the railway systems, or anything that you want to look around you and see that something can be improved, some energy can be saved somewhere, some water can be saved somewhere, or somewhere something can be used more effectively, I think you should then take that up as a challenge and look for support from IT people to provide you with the IT support and solve the problem in your domain. That is where the job opportunities are going to be a lot. And as entrepreneurs and startups, I would strongly recommend that you set up startups in those areas rather than going after IT. Yes, IT looks very lucrative now. There are so many unicorns in various service sectors who are doing e-commerce and so on and so forth, but that's not going to last long. And by the time you set up your startup and you grow into a mature company, there may be other domains which would be more conducive for your growth. So, next slide. Yes, so this is, next. Best time, this is the best time for entrepreneurs, as I would think, because if so far, I mean, we've gone through a stage where there was a lot of government control during our days, where being an entrepreneur was a very thankless job. And then there was a period where entrepreneurship meant that you set up things only as an IT company, and then people, investors and so on would look at you as a major IT player and support you. But now the opportunities for entrepreneurship is in all sorts of problem areas. So that is what this slide says. This is the best time because the big companies are not going to get into the kind of problems that you are going to solve. And the small companies are going to, the students and so on and so forth. This is the opportunity for you to get into that, to be able to grow into much bigger setups. The next slide. Yes. But at the same time, since there are other set of people here, the academic people and hopefully some people from the government and so on, I would really think that a strong entrepreneurial spirit, no doubt, is the core of the situation that can exploit this current opportunity. But I think the government has to also get into the act by strongly supporting the startups. Of course, government is already involved in a lot of things as far as incubating startups are concerned, supporting them with various infrastructure and so on. But the most important thing that the government needs to do is to provide marketing opportunities for startups. Basically, the startups need to have reach to the market with whatever ideas they have, and then the reach also, the biggest buyer in the market right now would be the government. For all the talk about private industries, possibly because of pandemic or even otherwise, the private people are a bit shy of investing in newer technologies and newer ways of doing things until after some time. So they are hardly the early adapters. The early adapters, I would still think, can be the government, and the government would have to play that role in encouraging such technologies. And they can take a risk. They need to come out with some better systems than the typical tendering system, and the lowest court gets the order and so on and so forth. There has to be much better frameworks to encourage entrepreneurs to go to the market. So, next slide. So, from sustainable energy, if you go to sustainable development goals, the UN has come out with the sustainable development goals, which are about 17, I think, in number. So, 17 goals are there, and the UN first came out with what they called as Millennium Goals, which was to have these goals by 2000, then they extended it to 2015. Now they have extended these goals to 2030, and most of the countries, including India, are a signatory to these goals. And if you look at these goals, they are all enumerating the everyday problem that we have, whether it is poverty, whether it is transportation, whether it is pollution, whether it is animal care, whether it is marine welfare, whatever you do. So if you just look at these development goals itself, it will tell you give you a lot of ideas for seeing what are all the areas that require improvement, and which you can think of as a good problem to solve for a startup that you want to set up. So I would really recommend you that as students, you should be looking at not jobs as your next destination, but look at opportunities where you can set up more and more of startups, and either the few, 3-4 people can join together to have a startup going. And I'm quite sure that you will think of that being far better in the long run than having to work for a company that is making a lot of money for some other company outside of India. So thank you so much. Thank you.
Thank you, sir. After that wonderful call for action to be responsible and the startup opportunities, we now heard Mr. Manu Iyer. Over to you, sir.
Hi, good afternoon. How's everyone doing? Just give it a second while they load the presentation. So while they're loading, I just, thanks for lending me your attention for the next 10 minutes. It's a very nice forum to be a part of. And I promise I'll be fairly quick and our slides will be fairly light. Okay, so I was given this topic a few days ago. It said opportunities in technology for sustainable energy systems. So I did what any one of you would do. I went to the all-knowing knowledge God. I'm sure all of you know him. He's everywhere. Google. I typed in this topic, and unfortunately the results I got weren't very helpful. There were some courses that were available in Sweden and in the UK, but otherwise I don't think it was very helpful at all. So then I decided to put my own understanding of what I thought the topic was. I think the term sustainable energy systems is all-encompassing. It's too broad. And so from that angle, I thought I would add my own understanding and my own focus on these areas. So with that in mind, I'll just quickly introduce myself. My name is Manu Iyer. I'm an electrical engineer from IT Madras. In my current avatar, I'm an angel investor. I've invested personally in over 50 startups. I work as a part of Blue Hill Capital. I invest in deep tech, clean tech, IoT, AI/ML, industrial automation, biotech to a certain extent, med tech ideas. So the focus that essentially I bring to the table is investing in ideas that are solving engineering problems. And so from that angle, I think this is as close to home as it can be. Doesn't work. Okay. So like I said, when I said sustainable energy systems, I think there are far too many things to cover. So I thought let's cover some of the areas that we are looking at from an investment standpoint, some of the areas that have been in the news recently, which would kind of be relevant for our discussion today. And largely thought I'd filter it down to 3 areas. Transportation, energy generation and storage, and agri. Okay, so this is a topic that was covered by the earlier panel as well. And I'm sorry if it sounds a little bit repetitive, but unfortunately, this is the area that is finding the most amount of traction from an investment standpoint. This is the area that is finding the most amount of engineering interest today, given that it is finding a lot of investment interest, right? There is a lot of capital chasing people solving problems in this area. And so let's look at EVs, right? Electric vehicles, and broadly the theme being the localization of the electric vehicle play in India. Okay, so electric vehicles, I'm sure as all of you are engineers here, are made up of a bunch of components. For the most part, the electric vehicle components are imported almost completely, right? There is very little that is actually done here today in a meaningful engineering and R&D standpoint, which is what is changing very rapidly. As an investor, we are seeing a lot of work that is happening on the motors front. New efficient motors that are coming into play. People are building motors locally where they are sourcing only the magnets from abroad, which unfortunately is a gap that we have to live with. We don't have that natural resource here in India. But otherwise, the rest of that supply chain, the rest of that manufacturing chain is happening in India. There are motors that are happening without magnets, as was referenced in the earlier panel as well. So a lot of new ideas are coming up in that space where manufacturing is being localized in the motor space, brand new technologies, permanent magnet motors, more efficient brushless motors are coming into the picture. The next piece, which is the cells and the packs, I think is most relevant, I think in conjunction with the BMS as well, given what we are reading in the news today, what we are seeing in the papers today. We have no real cell manufacturing in India today, right? Everyone who says I'm doing batteries in India is a pack manufacturer. So they're putting together packs for specific use cases, for specific capacities. They're putting it together, putting it on strings, having data leads taken out from that to supply data to the BMS. But otherwise, there is no real work happening on the cell front. The reason, or at least one of the reasons why we are seeing problems in the battery, problems in the EVs with regards to fires, while I think many of us have heard various opinions of it, at a high level, it is low quality cells that are coming into our ecosystem, which are being built into low quality packs without a proper BMS on top, right? Most of the time, it's a protection circuit, it's a cutoff circuit without any real logic on top of it. And the opportunities for the packs to fail are very high, especially given the specific conditions that are, that are relevant to India today, which is the most obvious being the high temperature. Other things being abuse of usage, overcharging, over draining of the packs, are some of the problems that we'll see. But in this space particularly, there is a lot of work happening. There's good amount of R&D happening in this space. I think, like I say, a little bit lower as well. A lot of work happening on new chemistries, starting from lithium iron phosphate to lithium NMC to lithium titanate as well. And within the NMC space itself, there are so many different variants, so many different percentages. You vary each of those and see how the cells perform, how the packs perform. And that is where I think there is a good opportunity for a lot of engineers to come in and contribute. to look at packs, to look at cells that are relevant to our ecosystem, to look at cells that are relevant to our use case, right, is very important. And slowly we are getting there. We're getting to a point where the cell manufacturing is also coming in very slowly. I think it will take some more time, but I think that is also on the cards where research teams are working on bringing in cell manufacturing into India. To a certain extent, it's being done for, I think, phone cells from prismatic packs and all that, but the actual cylindrical packs, there isn't manufacturing happening here at scale. The electronics part of it, I think that is very critical. The BMS, the VCU, other ancillary electronics that happens, and on the firmware side of it, I think there's a huge opportunity for people to contribute, along with the communication systems for charging infrastructure, the new protocols that are coming in from charging. There are opportunities for engineers there. Another interesting space, I think quite a few people are doing hybrids, where they say, okay, there is problems, or people have this mental block about electric vehicles because of range anxiety. So why not allow them to ease into electric vehicles or ease into these systems by continuing the internal combustion and electric vehicles at the same time. And so that is an interesting space. And similarly on that front, potentially lowering the cost of EV adoption is by saying we'll do retrofits. But I think retrofits work only to the extent that there is a strong enough swapping infrastructure in place. The other place where a lot of work is happening is in fuel cells and fuel cell EVs. Not too much has happened in India, I think, to that extent, but in terms of an R&D problem, I think it's an interesting problem to solve, both from a transportation standpoint, and I think I'll come back to this a little bit later, from an energy storage standpoint as well. So the next piece we were talking about is the energy generation and storage standpoint, right? And from that aspect, I think there are quite a few people here who have that background in solar, so I will limit my comments on this. But work is happening on improving the efficiency of the photovoltaic cells. We have seen, starting from the generation 1 cells we saw 10, 12 years ago, where 1 megawatt plant would have cost upwards of 12, 13 crores to about 4 crore, 4.5 crore all-inclusive 1 megawatt plant that we're getting today. Makes a huge difference in adoption of these technologies and bringing it into mainstream. The improvements from the first generation to third generation in terms of efficiencies, in terms of long-term degradation of these cells, to be able to give 90+% efficiency of the original rated specifications after 20 years, after 25 years, there's a lot of work happening on that space, bringing in organics into the equation on silicon, bringing in concentrated silicon ideas. The other space that I'm seeing a good amount of work happening is in the space of turbines. People are working on building more efficient combustion techniques, trying to get the best, trying to use multiple sources of fuel in order to, and be able to get similar outputs, agnostic to the calorific value of the fuel to a certain extent. Other ideas that are working are on 3D printing in the turbine space for quicker turnaround using very interesting materials, Inconel. A lot of alloys are being used in that space. And so there are interesting opportunities for various engineers, various fields of engineers, from material sciences to aerospace to just basic firmware, software writing stuff. There are good opportunities in that space as well. Again, I think when we come to storage, again it becomes, so when we look at lithium, or when we look at fuel cells or hydrogen cells, we look at it from two angles. One is from a mobility angle and the other is from a storage angle, right? So from a mobility angle, where they are the prime mover of the vehicle or prime mover of a car or whatever, bus or whatever else, which is a little bit more complicated, I think, when it comes to fuel cells, because they have to be rated for collision, they have to be rated for vibration, they have to be, rated for water intrusion and things like that. A little bit more complicated when it comes to fuel cells, but I think it's fairly set when it comes to the lithium side of things. And so there's a fair amount of work happening again in the fuel cell space in this area. The last area that I want to touch upon is agri. Again, when you think about sustainability, when you think about sustainable systems, I think agri has to play a big part in that story. And from that angle, I think there are multiple interesting projects and bodies of work that are happening in that space. The hydroponics is a very interesting area. I think there will be a lot of work that goes into this, a lot of capital that is chasing ideas in this area. Because the efficiency in water saving is incredible when it comes to hydroponics. The amount, 1/5, 1/6, 1/10 of the amount of water to grow the same crop. The ability to save space in a country like ours, where land is always at a premium, the ability to save space is a interesting problem to solve. We are seeing a good amount of work going into mechanization. Even things like tractors are being, people are building electric solutions to tractors, EVs, and the agri space. There is robotics and mechanization happening in that space as well. Interesting projects happening from fertilizers, improving the quality of fertilizers, specific yielding fertilizers, specific crop fertilizers, fertilizers that reduce the amount of space that is needed to carry essentially more potent fertilizers are being built. There are ideas coming in from that angle as well. And finally, I think the big idea that everyone is excited about, the government is excited about, a lot of startups are working on, is drones. And there are applications, very specific applications of drones in the agri space, from pure and simple fertilizer distribution to pesticide distribution, and automating that process itself, right? You have a drone for a large farm. The drone has a schedule, a computer-driven schedule that is already built into it. So the timelines, everything is built into the software. And another very interesting use case is the GIS mapping, GIS and mapping part of the drone story, where drones are being used, the same drones that are being used to distribute fertilizers and pesticides are being used to collect data, being used to collect an understanding of what crop is being grown, what is the, how has that progress been, build that feedback loop, build that information database, and kind of feed that back into the various agencies, the various people who look at it, to help make the decision-making process a little bit more robust. So these are some of the areas where I think as an investor today, we are exploring, we are spending time diving deep into some of these ideas to see which ones would make a difference. So in conclusion, I think the first point you guys would have heard over and over and over again, but I think it's a very relevant point. And today, there's one single event that has happened in the last, 2 months that has made this all the more relevant, right? The Russia-Ukraine war, right? Overnight, the entire American ecosystem pulled out of Russia, right? They pulled their financial ecosystem out. They pulled their, restaurants out. The restaurants who said they want to continue are boycotted. So I think it becomes extremely critical, and it's more obvious today than it has been ever before that we need to own our own rails, right? And when I say rails, it means multiple things, right? It means the base on which technology works should be in-house, meaning it should be indigenous to us, it should be indigenous to India. We should not, while it is, okay to learn from that, learn from stuff that's coming from outside, I think it becomes the need of the hour, whether it is the financial rails, the UPI, the base platform, or whether it is the technological rails for mechanical, electrical, chemical systems. It's the need of the hour that this is all now built in India and built in-house. So obviously, as investors in the space, we are as excited as can be because this is now a problem that needs to be solved locally. There is excellent engineering talent in the country. People much like all of you guys. India is an excellent place to do low-cost research and development. The facilities at institutions such as Anna University and a multitude of others provide us the opportunity to do research, provide us the opportunity to do, provide us grants, low-cost funds to experiment today. I think opportunities that were not there 5-10 years back is now available to all of you guys to experiment, right? All that is required is that, to have that inquisitive mind to say, okay, I want to try out something, I want to solve this problem, and I want to, try this out. And today the ecosystem is so strong, that people are all around you to support, right? We are, one small cog in that ecosystem. After you guys have built that basic structure, we come and fund it. But today, the mentorship ecosystem, the type of organizations, your own entrepreneurship cells within your own colleges are all very mature. And I think it's high time that people utilize all of that. I think India is a low-cost test bed for many ideas, and I think the ideas that have worked the best are ideas that are built in India but built to solve broader global problems. And so I'll just leave you at that. Thank you so much.
In sub-conferences, so I can see that my job is going to be easier. Before the PowerPoint comes up, many of the things have been done by the two previous speakers. I'm just going to quickly run through some statistics, some numbers for you. What is there in store for youngsters like you in the renewable energy sector? And renewable energy sector, as you know, is a multi-physics, inter-engineering, inter-science, physical science together. So I think, is it coming up? Yeah. Keep the first slide on. Yeah, I'm just throwing you some highlights here. The small wind sector, which is yet to get a boost in India. The small wind sector. But I'm sure with the EVs proliferating, at every 50 kilometers, you need a charging point for two-wheeler. At every 100 kilometers, you need a charging point for car, for a medium rated car. Otherwise, up to 300 kilometers. Today, I think in the newspapers, they have also flagged battery swapping technology to be included in the policy of EV vehicle in Go Electric India mission. So renewable energy, all of you know The major things are solar and wind. I think there is no pointer here. Okay. The wind sector, you will find in one windmill there is 14 megawatts installed. Can you imagine? In one windmill, 14 megawatts installed. It is in France, Paris, near a port. That means the size of the blade is about 120 meters and so on. It has to be carried by multiple trucks. And there are mega solar farms, grid-connected solar farms, and rooftop solar, all of you are aware. And small wind is yet to pick up in India. But there is a lot of scope for 7,600 kilometers in India, the coastline, which has got land breeze and sea breeze. Everyone can have it. Only thing is the investment and the maintenance for wind machines are a little bit complicated than the simple clean and watch the connection kind of a solar PV project. So, next slide. Sorry, in one press it goes very fast. Can I go back? Yeah. Okay. What we mean by sustainable? What we mean by sustainable is shown in these two pictures. So mostly I am showing electric vehicles, electric traction in railways, and battery swapping technologies, fast charging systems, and so on. At the same time, there are simple techniques every one of us can do, following the traditional way, drying your clothes instead of using the dryer. Every unit of electricity saved, you are saving the world from getting polluted. Because even today, 60% of the electricity in the world, or 70% is being generated using coal, fossil fuels, which has to change over the years. So what we mean by sustainable is to use public transportation. Again, we are coming into COVID scenario. We cannot use public transportation the way we used to use. Crowded trains are not possible now. So there is a mix of everything in what we practice as sustainable. One has to go through. I will leave the slides for anybody to copy. The organizers will give it to them. I'm not able to read partly because I don't want to read everything, given the short time. Now let's see. Okay. Tech-wise, Irena, I'm just concentrating on two reports from Google because I have retired 5 years back. My connection with the industry is limited to my consulting. Okay. So I'm just using two reports. One is Irena Job, RE Renewable Jobs Report 2021, which gives you tech-wise what is the possible scenario. And also another report, which I'll be coming soon, Getty. Getty is Global Energy Talent Index. So that gives you over a 43 questionnaire survey to the people who are working in the industry world over. About 1 million responses to 43 questions have been analyzed. Year on year, the Getty report is being published. What is the salary level? What is the kind of roles one can play in renewable energy industry? And what is the contractual cost? So all these things are given in the next piece of report. So what you see here, India is also, there are the 12 million job opportunities in the renewable sector, which is almost 3 times more than any energy sector, overall energy sector. 3 to 4 times more than the energy sector. And maximum opportunity is provided in China, 4.7 million. India comes about 5th or so, 0.726 million jobs are generated. Some more exact numbers from another source is about 0.835 million jobs. And you see at the box, the colored box, what job is available in which renewable energy sector. So here again you see various, the solar PV sector gives the highest of the jobs available today because it is highly decentralized. You can have distributed energy systems. you can become a prosumer, producer come consumer. That is by net metering technology and so on. Everybody who has got a well-lit sun roof, they can have their own power produced and use it and reduce their bill, electricity bill. So there is a lot of demand for it, and the skill set development is also probably a matter of 4 or 5 days. You can develop a rural, semi-educated person into assembling a solar panel on the roof and maintaining it. So the job opportunities in the solar PV is very high, 3.7 million. And there are already Surya Mitras which are promoted by Ministry of New and Renewable Energy. Every year there are so many certified programs, certificate people go out and serve the rural energy needs. Okay, there is a very good possibility now with a microgrid or mini grid development to put up electric charging stations all over the rural sector. So, because we have 300 days of sunshine all over India, we have very sea breeze, land breeze, entire coastline. So, you combine this wind and solar together, you can put micro and mini grids to charge your EV. So, charging the EV becomes fuel-less, naturally fueled. So, this is going to pick up very soon. This is a slide from Energy Storage Alliance, Dr. Rahul. And next we will go to country-wise renewable opportunities. India stands again one of the leading renewable energy job providers. What you see on the left side is the US Clean Jobs report. That again gives you solar as one of the dominant job creators. In India also, the solar is still a very good job creator. Kindly go through the reports for more details. I don't want to, within the short time, I will not be able to cover. So I have given in my website, if you go, there is one Tamil 1 hour session on sustainable global energy transition. I call it acronym SGET. And another with the Visvesvaraya College of Engineering, which was an invited talk, 1 hour, which is also YouTube, link is there, where you can see more about the technology. Now let's talk about what are the technologies, what complications are there. Is it India, why India has not gone for offshore so far? Is it so easy to migrate from onshore wind to offshore so easily? Not so easy. Because the onshore wind, if you take 6 crores per megawatt, the cost of equipment, wind turbine, blades and other equipment will be about 70% of the overall cost. 30% will be the balance of plant, the civil foundations and erection, commissioning, maintaining and so on. Whereas when you go to offshore, the scenario is totally different. It is just the ulta, just the reverse. That is, a lot of blue-collar jobs are available in the offshore wind industry because it is 70% is erection, commissioning, installation, geological surveys, underwater surveys, underwater commissioning, all those things to plan for the foundation and so on. The cost of the equipment is only 30% of the overall cost in the case of offshore. So India is heading for a big offshore project. 350 crores has been sanctioned to set up an offshore plant in Tanushkodi. Recently, National Institute of Wind Energy, where I was there 8 years, is now taking up the job to put up the prototype plants in offshore in Tamil Nadu. A lot of opportunities there. It's a highly paying job. Okay, next one is waste to energy. So you have, every one of us generate waste. All of you agree with that. Solid waste management has been realized very, very lately. Waste to wealth is what we are embarking on, but it is a very low process. If you see at the bottom, how much carbon can be saved by converting the dump yards which are emitting methane, that can be very nicely captured using porous tubes and systems which are being done in Sweden and other countries. So every methane can be captured and it can be used to generate green hydrogen, which is a promising fuel for trucks long distance trucks instead of it is already being in practice in US and Europe in many places. Next, let me quickly go through. And whenever it comes to renewable energy, people talk about it is inform. Wind suddenly stops, or the solar is clouded, the sun is getting clouded, the energy goes out. Now it's not the place with ICT, information communication technology, AI technology, industrial Internet of Things and industrial Internet of Things. They have facilitated now forecasting possible for every 15 minutes what will come from which renewable energy source into the grid power. So right now, the Australian wind farms are being monitored in Perungudi. Hope all of you would have an opportunity to see in the Perungudi control station of Vestas. So that's the kind of technology that is available. So I'm a civil engineer, I'm talking about this. So like the first speaker said very, very well, you have to keep your these things open, your eyes open all around you. Grab the opportunities. That's how we have to move further. Because, 10 years back, everyone joined IT industry. Every core engineer and topper will be joining IT industry to code some software lines, which is not the one which he learned to be practiced. Now the trend is reversing. So now there is an opportunity. Whatever engineering you do does not matter. There is a merger of several disciplines today without which you cannot find a job or you cannot start a company. That's how it is. So remember that. So you have to be keeping open. Go Electric is launched 2021. I think I don't want to talk about it. Many authors have already talked about it. It's picking up very fast. And Chennai has already become a Detroit, giving spares for automobiles. And probably soon it will also become a very good hub for renewable equipment manufacturing. And let me skip this also, Go Electric. Many things have been covered. And key technology, when you want to establish a charging station, it will be much less than the petrol bank to be established. The cost of it, depending on the capacity of the charging station, you can establish with much less cost than the petrol stations, petrol pumps. Right, hydrogen is being propagated already. Hydrogen as an energy for carrier, and you can fill hydrogen in hydrogen station, which was given free of cost by Toyota some years back. The patent was given for anybody to set up a hydrogen station to power their hydrogen vehicles. So you can fill it just like petrol. You can fill 2 to 3 minutes. You can fill up and travel for 500 kilometers and so on. So that's also it's oncoming technology today, with the green hydrogen being focused today. Hydrogen mission also has been launched in India. Right, hydrogen production and infrastructure is in multiple ways one can produce hydrogen. Hydrogen is also one of the raw material for ammonia, fertilizer, so many other things. The Sweden and Switzerland has already started using, instead of coal in their steel plants, they started using hydrogen as fuel, as energy. So this is a very gray area which has to be captured. Now let me come to quickly in a couple of slides I'll be highlighting on Getty report, which shows that this is I'm not able to read. I have a small problem. So you will find, all of you young eyes, you can read the kind of jobs you will get in renewable energy. What roles as RE jobs? You will find this is all in annual income pay, which is declared by the employees from several companies from 170 countries. Okay, it is in 40,000 or 30,000 average US dollars. I'm sure you will find this is highly lucrative, and you may ask me, we are not getting that kind of salary in India. India has a lot of manpower. What is required is just pick up a bit of skill set in the domain of the RE, then you will land into the other things. If you find these jobs, you will find 1/3 of the jobs are with management function. So all engineers should understand what is business case, what is cash flow, what is the business, what if I do this way, how much I can save to the company or to the nation. This is the kind of thinking what you need. The managerial aspect has to be built in your final year career. There is an opportunity by International Project Management Association. The final year students can get certified, if not MBA degree, you can get certified in IPMA D level. That certificate is valid all over the world, and you will be able to appreciate, organize yourself well as you will understand the business case where you are going to work. This is the kind of salaries. Please go through the report. It is downloadable in the website for details. And as a contractor, you'll always have a premium. The contract daily wage will be much more than the employee salary. So that means if you are a high risk taker, you can start your venture capital and do this service that is required in the renewable energy sector. And it will be almost 1.5 to 2 times more than the employee salary. That's what you get because it is temporary. You do the service for a short time. Okay, I think these are some of the question and answers wherein you will find what is driving me into the sector. You will find here, I think, the 20 to 35 age group of people are the maximum in the renewable energy sector, and they also get paid. And the renewable energy sector is heading for 12 million jobs in 2030, and 32% is going to be from the female gender. So it is. It's not coming. Outside that. Okay. Yeah, and the Getty and IRENA report says what are the ways one can be ready. The practice school, practice which is there in US, so that is, they give a orientation to face the company directly. So not the first ranker will always be taken. Why the companies conduct interview? It's not only the first ranker they want all the time. Depending on the job requirement, they want an overall performer. So you need to be ready for the industry. Get some accredited certifications while you are doing the course itself. I think in India, there is a National Council for Green Jobs, and they address almost all the sectors in renewable energy in India. It's a very organized sector. I think Raghunathan will agree. He is one of them who started decades back, sending people to Singapore, training them in solar PV, and get them employed or get them make a startup themselves. Am I right? I think that's how he did it. So that's the way you have to think out of box. Please think out of box. Don't be contented with what you get a degree with a university rank. Okay. And last few slides I am completing. IRENA has very clearly said there is a possibility we are the generation which can save the earth. That is 36.9 gigatons of carbon can be removed with 25% renewables, 25% jobs from energy efficiency, electrification by another 20%, and so on. By electrifying, India will save a lot of foreign exchange. 85% of the fossil fuel is imported in India with dollar payments. By electrification, when you use renewable energy, this can be very, very, very well saved. And this slide shows you what we are here in 2021. About 51% of the electricity is direct use. In 2050, we should use 50% of the electricity for direct use of electricity. And that electricity, 90% of it should be generated from renewables. That means you can imagine the kind of job market available in the renewable energy sector, and it is a highly interdisciplinary, merging science and engineering together to give you a viable opportunity. This slide I am just flagging here. We have enjoyed, I'm 65. If I live for another 20 years, I might see the petrol banks empty. Fossil fuel may be not available so easily. Now itself the cost is 100 plus. So, and the emitted CO2 by me will remain for 120 to 150 years because it's the life, it's the residual life of the carbon dioxide unless it is captured and saved. So renewables play a vital role in getting the sustainable global energy transition, and both solar heat energy can also be used very well, and we are not thinking about it. In India, there is a big promise for solar thermal to be used for air conditioning. There are already people who have implemented 40 ton and so on, turbo energy, and wind with wind, onshore and offshore, even land breeze, sea breeze in the sea coast, you can combine. And think small, do and get it done by the mass. That is rooftop. If everyone goes for it, then you are going to relieve the grid of a lot of money, the grid coal-produced electricity. That's what is required. And informed renewable energy is not anymore. It can be very accurately forecast with the AI techniques. We have demonstrated in Tamil Nadu. Now the evacuation of wind energy and solar energy in Tamil Nadu is almost 85 to 90%. No backdowns. God has created no waste. Waste is wealth. See, work for it. Future of sustainable mobility is using IoT, ICT, IIoT, and so on. I think we are the only generation we can save the future. The answer is act now. Many children talked in COP26. You remember, don't keep on talking in seminars and conferences like this. Act now, save world's energy resources. That's the answer. How do we do it? Reduce carbon emission, reuse without any waste, and recycle material. This is the strategy. Think global, act local. This is my message. And youngsters, you are more than a supercomputer in the world. Only human brain can think and innovate. Please do that innovation, creativity, and do contribute to India's wealth and global wealth. Thank you.
Thank you, sir. That was phenomenal. And youngsters, how many of you saw the opportunities coming up in front of you? I saw at least 100, 200 opportunities in the last 1 hour and 30 minutes. It was phenomenal. Thank you very much, sirs. And volunteers, could we have the felicitation even for the speakers? If you have any questions or any clarifications, the volunteers are there. They'll be handing over a small slip of paper. Please write your name, your query, and to which speaker, and please give it back to the volunteers. It will be addressed today evening or tomorrow evening. We will come back to you on that. Dr. Rajaram, thank you very much, sir. Let's give them a big hand of applause. Mr. Manu Iyer, thank you very much. Dr. S. Gomati Nayagam, it was wonderful, sir. You produce and you consume was an excellent takeaway from your session. Thank you, sir.